All right, class, we're on our next lesson. We're going to prove lines are parallel. It doesn't change much from yesterday's or Monday's lesson. On Monday's lesson, what happened was I told you, hey, here are parallel lines. That means that the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent, and then consecutive interior angles add up to be 180 or are supplementary. When we go to prove lines that are parallel, what we deal with is what's called a converse of each one. And if you remember from converse, it's just switching the hypothesis and the conclusion. So in this case, we're actually going to say, oh, okay, the angles, the corresponding angles here are congruent. That means that the lines are parallel. The alternate interior angles are congruent. That means the lines are parallel. And then if you go down to consecutive, I have the two interior angles that are consecutive, or the two consecutive angles, interior angles are adding up to 180. That means the lines are parallel. So if we take a look at this example up here, if we look at corresponding angles, let's look at angle 1, angle 5. So if we look at angle 1 and angle 5, those are corresponding angles. I can safely say, if I'm going to prove that those are parallel, I can go, if angle 1 is congruent to angle 5, then line L is parallel to line M. If we're looking at alternate interior angles, let's choose angle 4 and angle 6. Safe to say, if angle 4 is congruent to angle 6, then line L is parallel to line M. If you're looking at alternate exterior angles, let's look at angle 2 and angle 8. If angle 2 is congruent to angle 8, then we can say that line L is parallel to line M. Then lastly, but not least, we look at angle 3 and angle 6. Those two are your consecutive interior angles. So it would, if angle 3 plus angle 6 equals 180 degrees, then we can safely say that line L is parallel to line M. Now, what I want you to see here and what I want you to take from this, at least the shortcuts, is that every single one of these, when we did angle 1 and angle 5, they shared a transversal. You're going to see problems where there's going to be multiple transversals, and they're going to ask you, give me the two lines that are parallel because of these two angles. That means you'll have to go in there and say angle 4 and angle 6. Okay, so here's angle 4, here's angle 6. Both of them touch a common transversal. If they don't touch a common transversal, then they're none. You cannot classify them. You cannot say the lines are parallel because they don't touch two lines. They don't touch a common line. So there would be, your answer would be none. All right, so here's the example. Here we have these four lines all intersecting each other, and we have to assume, or we're going to prove, lines are parallel just by what is given to us over here on the left hand column. So let's look at each one of these, and for us to be able to call any lines parallel, let's take for instance 1A, those two angles, say angle 2 and angle 4, both have to share a common transversal. If they do share a common transversal, then the other lines that they touch are the lines that are parallel. In this case, angle 2 and angle 4 touch this line together, which means these are the parallel lines. So I would say C is parallel to D. Why? Well, angle 2, angle 4, these are corresponding angles. So the converse is the corresponding angles. So now we move on to angle 5 and angle 10. Let's clear this. Angle 5 and angle 10. Here's angle 5. Here's angle 10. Let's see, they both touch this line in common. That means that angle 10 touches this one, angle 5 touches this one. So these two, line A is parallel to line B. These two right here are alternating interior angles. We're here on C, measure of angle 6 and measure of angle 10. So we look at angle 6, then we look at angle 10. Both of them share a common transversal. They both touch two separate lines. They're on the same side. They're consecutive interior angles. So these are my parallel lines. A is parallel to B. And they're parallel because of consecutive interior angles. All right, let's go to the next one. Angle 1 and angle 14. So we have angle 1, angle 14, share a common transversal. So 14 touches this one. 1 touches A. Again, A is parallel to B. These are alternating exterior angles. And we keep moving on. We go to E here. We're looking at angle 14 and angle 15. Let me erase this up here. Let's go to angle 14, angle 15. Both of them share this transversal, but now angle 14 touches C, 15 touches D. So because they share their transversal and their consecutive interior angles, Well, that means that C is parallel to D. What's my reasoning, or what's the converse I'm using? It's consecutive interior angles. And we keep moving. Angle 11 and angle 16. Okay, let's see. Let's look at angle 11, angle 16. We have angle 11, we have angle 16. Whoa. Let's pump the brakes on this one. They share that one, and they share that one. There is really no parallel lines. None. There is no converse. Let's look at angle 4 and angle 15. So we have angle 4, we have angle 15. Both share this common line. 15 touches B, 4 touches A. So we have A and B parallel. Angle 4 and angle 15 are alternating. Exterior. Look at angle 10 and angle 12. 10, angle 12. Both of them share this common transversal. Good. 10 touches C, 12 touches D. We have our parallel lines. C is parallel to D. And 10 and 12 are corresponding angles. Measure of angle 9 plus measure of angle 13 equals 180 degrees. So let's look at those two. Angle 9, angle 13. Again, they share two lines in common. That's a no-no. None. There is no converse. Let's move to our last two. We have angle 2 and angle 7. Let's zoom in. We have angle 2, angle 7. Okay, so they touch this one in common. Angle 2 is connected to C, angle 7 is connected to D. So we do have parallel lines. We have C is parallel to D. And they are parallel because those are alternating interior angles. All right, we're on our last one here. Angle 6 and angle 11. That is a big flag. We have angle 6, we have angle 11. Angle 6 touches this line and this one. Angle 11 touches this one and that one. None of them share a transversal. So automatically, because they don't share a transversal, it is none. This is what you will have to do for part of your homework. I will go over 2 in class. And then the proofs, well, if you look at the proofs, you're really just giving explanations as to what is happening. Why are they happening? I'll go over one. Let's go over number 3. What is the first reason? Well, the first reason is always the given. If I have two angles that add up to 180 degrees, well, that's the definition of being supplementary. because of this, they're parallel. That means if they're supplementary and they're right next to each other, then they are consecutive angles. Interior angles. That's how proofs are done. But the bread and butter of this is the algebra. Okay, none of these are stated as being parallel. What we have to do is we have to assume, okay, we have to prove them parallel. And it's if you ask me, this is exactly how the work was, or the homework for Monday's assignment. First thing you got to do is classify them or find the converse. So if I look at number one, what are these two angles? Well, these two are alternating interior angles. By definition, alternating interior angles, for them to be parallel, are equal. So 10x minus 23 equals 137. 10x is equal to 160. And x is equal to 16. Should be able to do that math. If I look at number 3, this angle right here is 96. This one right here is 6x minus 30. Those are, I'm classifying them first. They're consecutive interior angles. What can we say about consecutive interior? Because that's what's going to help us with the problem. They add up to 180. So these two equal 180. 6x minus 30 plus 96 equals 180. 6x plus 66 equals 180. And then we move the 66 across. And we get 114. Now we divide by 6. X is equal to 19. And we keep going. Let's look at number 8. Here we have this angle. Here we have this one. Remember this symbol? T equals 90 degrees. This angle and this one, if I classify them, they're corresponding. And what can we say about corresponding angles? Are equal. So I can say 4x minus 18 equals 90 degrees. That means 4x is equal to 108. X is equal to, I believe it is 27. Yeah. All right. Your homework, you have 1, 3, 5, 7, 9, and 10. 1 is probably going to be the hard one. I will go over this mañana.